は後方ですか？ Hi, good morning and salam sejahtera to everyone. It's indeed very good to see you all again joining us for this third series of the whole month, 4 days training. So today is the third day training. The topic will be Wolfram programming language made simple. Okay, it's very happy that you all can join on time. And I would like to introduce our speaker for today. Our speaker for today is Mr. Peter Lim. Our company director, and he himself is a senior industrial trainer and also expert in AI machine learning. Mr. Peter have more than 25 years of industrial experience with many long-term collaborations, relationship with industries, university, and throughout Malaysia, Singapore, Thailand, Indonesia, Taiwan as a project consultant, coach, trainer, and agenda lecturers. He delivered over like 300 sections of workshops, public seminar, industrial talk, and also educational conference since years 2008. Okay. So today he will deliver the whole section, and I, Desmond Lim, if you will join us in the last two sections, you will know me already, and I will be collaborating in the chat room and also Q&A. So if you have any questions, you can always type in the chat room or the Q&A so that we also can answer you right away. And just a last reminder that certification of attendance today will be available at the end of the sections. So stay put with us. I will provide the certificate link at the end. And for today's handout, I will put in a chat room in a short while. You can go and download it. Let me put in a chat room so you can go to the cloud to get access to the handout for today. So without further ado, I pass the time to Mr. Peter Lim then.
Thank you very much, Desmond, and good morning and salam sejahtera, and good to see many of you again joining the third session. Now, those attend the first sessions about 2 weeks ago, and you still could remember quite well about introductions to Wolfram language and covering the basic capabilities of Wolfram, some of the wonderful and powerful features of Wolfram Mathematica in version 13. So, and also last week, just last Thursday, and you also seen that how Wolfram is very powerful with curated data as a knowledge-based search engine. So many of you are actually been wondering what's different between the ordinary day-to-day search engine like Google things like that, compared to Wolfram so-called curated knowledge-based search engine. So those who came last week, you realize that in fact, there's quite a huge difference between these two, and the purposes and the reason are using two different search engines are meant for entire two different good reasons. So again, if you somehow are attending for the very first time today, doesn't matter, either you are actually a completely new audience to this talk about Wolfram language, or you have been a user of Wolfram technologies for a while. I think both of you coming from two different walks will actually today, after 2 hours, you have different takeaway. Yeah. So if you have been users, I hope that today what I'm sharing, so-called programming essentials, might add you extra tips and some of the little secrets that you might not realize before. And if you are new to these sessions, that you might not necessarily have to dive into immediately what we have shown into something that you can master right away. At least you know what's available out there, how you can get started easily. So we'll leave you with some of the directions and important information, how you can get started. Hopefully that help you to get on the foot in the right way. Yeah, instead of you simply searching for here and there to wasting unnecessary time to how to get started. So now, today we have 2 hours. For first half an hour, we allow you to have some time to sit back and relax, to have some understanding about background when call this Wolfram programming essentials, so that after half an hour and between the half an hour, you have time to download the link that Desmond has given and posted on the chat room. So when you can download it and you can open it and try to make sure that you can run it on your local system. If you somehow you cannot run a local system, at least you can open up and view it and follow through for the remaining 1.5 hours. So be chill, relax. If you say, I haven't had time to download yet, I haven't time to open, not worry. You have half an hour. You can open either later or after half an hour. We want to get started a little bit hands-on, but now no hands-on at all for first half an hour. Now, it's a little bit quick introductions about this Wolfram sandbox. Yeah, Wolfram sandbox, you can see there's the link here. Yeah, after you're able to open up this notebook file, like what I'm showing on the screen, the little link down here, if you click on that, you point you to, in fact, when it's called this sandbox, is none other than actually Wolfram Cloud version. But this Wolfram Cloud version, what it requires you to do is to do a basic registration, and you can come inside here to actually do some computations and also run this entire notebook, just like what I'm showing on the screen. What I'm showing on the screen here is so-called desktop version. So it's running on my computation powers and my own laptop resources. But if you choose to open up using this link, then you can go inside there, you give it an entire empty notebook. You can actually start doing some basic computation line by line. Of course, because it's sandbox means that a place for you to do experiment. You'll not allow you to do complex computation that will take like maybe 2 or 3 minutes. Yeah, the system have automation, automatic timeout, I think every 30 seconds. If your computation is not complex, that is actually could come out solution between a few seconds time, you allow you computation go through. So it's not meant for you to do a whole data project there, but it's meant for you to at least a place to experiment on if you do not want to choose to install any training license on a laptop or any mobile device. Now, if you look at about what this Wolfram is all about, why we actually been parading. I have a big twist of tongue recently when trying to recover with COVID. Now, this why we have been trying to parade this so much is Wolfram have very solid background history that we feel very proud of. First is the world's first computer algebra system. We say computer algebra system, what does it mean? In other words, actually it means symbolic algebra system. Symbolic algebra system means that any mathematical software, yes, Wolfram originally when first developed in 1980s, about 40 years ago, 4 decades ago. It's a very established company when it came out 40 years ago. it was the world's first mathematical computation software. Mathematical computation means it's designed to resolve complex mathematical and engineering problems, yeah? And allow people to key in symbolic symbol, just like how do traditional handwriting calculations directly in the computer codes, that you can understand it. So we call computer algebra system. It's the first in the world. Then after that, people follow suit. Of course, today there's a so-called computer algebra system, CAD system, or symbolic algebra system is something that become a world norm this day. Now, you look at the actually developments from there on, and previously people used when look at this one as a mathematical and advanced engineering computation package. They look at that as a symbolic computation engine. They use it in science, engineering, math, computing a lot. And this one becomes a major flagship product. And we have a desktop online version this day. Yeah. So if you want to actually leverage a more computation power from ordinary to more computation power, you can choose to actually purchase a subscription value you wish to opt for. So it's called Mathematica. But ever since 10 years ago, people find this whole thing is actually far more than what people expected. It's no longer just people who are doing serious R&D who find it actually is a so robust computation engine, but itself, it could be used for entire development and deployment. When you can deploy and develop, meaning that if I come up with my solution, I want to be able to deploy it so that I can share the result and become a solution solver. So it slowly actually naturally evolve into a programming language. So rather we call scripting. Because Wolfram is designed in a mind, is a symbolic computation package, most of the thing is you type in as how we write. So slowly evolve into a natural language style scripting programming language. Scripting means that you type as plain English and Wolfram make it as close as natural language possible as this day. And yet, even though it's such a high level scripting programming language, it allows you to go a low level, just like C++ level, because it's written in C++, yeah, or Wolfram. Now, Wolfram language now becomes something that empowers Mathematica from Alpha, Wolfram development platform, and along with many other Wolfram's products that actually making a market leading solution this day. So now, further move on, let's take a look here. And we look at not just whole globally, but look at Malaysia per se. We know globally, right, if you look at the world top 200 rankings universities, all of them, either they have an entire campus site license or some individual lab license. Now, you look at Malaysia here, almost all the IPTA and private colleges, big or small, they either have campus site license, individual licenses, or network licenses. They have been our users for the past 15 years and above, many of them. So we have many good friends like some of you being a good friends of us. So now this has become a very vibrant market. Now, despite the fact, and there's a lot of other rising technologies going on this day. Yes, it's good things, technology being competing and technology being rivaling. So there are major improvement and breakthrough throughout the year. Especially there's always a talk between this and that, between open source and proprietary software. Yes, some of you, if you are new to this free talk, Wolfram is sole proprietary software. Yeah, so proprietary software this day, the trend is in order to make it to be like adding value to users compared to the users who prefer little initial investment, they had to make sure proprietary software had to make sure that it would deliver something that allow you to achieve result in a very compressed time, so that you can justify what you're paying for actually work from what you're saving from licensing. Yeah, in terms of results. Yeah, in terms of accuracy, in terms of speed. So of course, one of the trend in the market as well is a lot of proprietary software are giving out more and more actually open developments that free for users. So that's why Wolframs are giving away like Wolfram Alpha, the search engines. Most are actually functionality free. Wolfram also giving a lot of development license some of the license here and there for you to try out. But today we're not here to talk about licensing, but just to let you know, to work with Wolfram technology, when you look at that, you will marvel about how powerful they are. You do not be worried about licensing. Yeah, you can talk with us first. Now, the reason is when the whole thing is start evolving from a traditional people looking at this kind of so-called CAD systems like 30 years ago. Oh, it is an advanced mathematical and engineering solver. Now, this day, the thing is because with the improvements of the GUI interface and integration, and entire Wolfram's actually so-called platform or Wolfram language, it becomes a language that people actually can use it naturally to represent their ideas. Yeah. So when it can be used to represent our ideas easily, that means that we can use it to translate or to represent or even to further visualize our idea. So it becomes an ideal tool for computational thinking. Yeah. So now, if you think that if there's any language that could be easily used to teach computational thinking, then this language itself must be something that very easy to master, yet it's powerful to do a complex development in computation. Wolfram is one of the typical examples. So now, if you look at computational thinking, where people do not look at just coding per se, say, oh, how powerful our coding are, this and that, yeah, or how robust entire libraries and packages. We don't look at just that. We also look at it technologically, does it actually compatible with a lot of computer science developments, like for instance, and data exchange, how it handles actually certain types of computations and where they actually fit into certain hardware architectures. These are part of consideration. Yeah, of course that it have to be well represented and be understood and accepted by people coming from different actually domains, so that people from different domains, not necessarily coming from computer science. And today what people have been advocating in STEM education also is we want to teach our students or new generation to resolve issues and problems like computational thinking. Because computational thinking is today with computers so much easier to adapt. Things are not possible or difficult in the past. Now it's easier. For instance, how do you actually resolve problems? Let's say I want to send a drone to Mars. What do I do? First thing I want to decompose it. Decompose our problems. Okay, decompose means that from here to get to Mars, what do I need? I need a rocket. I need the Mars lander. I need a certain team of people. Then after that, in this, do we actually can recognize a certain patterns? Yeah. If there's a pattern, could we actually generalize it or using some mathematical equation to model it to represent it? If I can, then quite likely I can use some mathematical equations or algorithm to automate this whole process. So this entire actually computation thinking now make it so simple with Wolfram. Then later I show to you why and why this is so important. So now, that's why just now I use this landing a drone in Mars as an example, because human already did last year. Last year is one of mankind achievement, landing a drone that actually will fly on Mars surface last year. So, and this whole thing here is you can see computational thinking, right? How we actually human approach issues and problems scientifically and engineering manner. Actually, it can cut across all different walks of life. Now, you look at the Wolfram speed and power in past actually about 40 years. Yeah, this thing, of course, is not like necessary for you to remember. Just let you know in now. If you're some of you, I'm get to know some of the users of Wolfram since version 8 or 9. And this is like every jump of version of Wolfram represent a major jump. Actually, in entire technology development in the market. It's not because software want to upgrade it. So people have actually so-called to stick with more faster computations and But most importantly, of course, each version of Wolfram improved a lot into the speed and efficiency and computation. They did a lot of updates in the algorithm. But importantly, I look at showing you the functions that built in Wolfram's. Each version may have major jammings that actually is a major developments in market or new mathematical computations. Allow me 1 minute. I go and take one coffee drop to make sure that it goes on smoothly. Okay, thank you. Now, if we look at the every versions, right, they almost usually additional 5, sometimes is even as unprecedentedly about 1,000 functions. It means actually it's major breakthrough in some technology areas. So Wolfram added in a lot of new functions to represent the advancement in the sectors of research. So even in this chart is already about 8 months old. The latest charts are given that is already exceeded about 7,000 functions. So now, if you want to install Wolframs, right, one of the minimum requirements that you need at least 40 gig of local space. So this that much actually information that Wolfram actually provided. But this haven't counted those online data Wolfram able to allow you to access. Only so built-in functions as an entire integrated package or at least 40 gig. Of course, today to a lot of PCs, right, 40 gig is nothing. Especially if we subscribe to online Wolfram packages, right? This actually space is not to your concerns, but rather we are very happy to see that how actually technology advanced along the way. So now, if you look at how actually the design of Wolframs, right, it cover actually, it cut through many fields. So actually, it helps us to grow along. Either you are in a field of educations, and eventually you are coming to more R&D to publish a thesis or come up with some research, you want to commercialize it. And even in the coming all the way, you say, hey, I'm going to develop this whole thing into that something I will publish and distribute. And even I want to just publish on paper and to make it a presentation or share my student assignments and projects and make it a textbook. And all myself that more interested in data analytics and actually integration, part of integrations, integrated solution in my company. This whole thing actually is all come together with a single installation and package of Wolfram. Now, this is how actually robustness is when first Wolfram get designed in its mind. Now, look at this whole thing here. Now, this is something that you don't need to click and run. Yeah, this is something I've seen it in the last 2 Thursday away. Yeah, also last Thursday. But today it's just a quick refresh of mine, just about 1-2 minutes. Yeah, to let you have a quick look at. You look at ordinary computations. When you say natural language approach scripting, actually, what idea does it mean? So if you want to solve a simple thing here, if I just click on this thing, of course, if you click on this thing, I do not do a computation on my screen. It directly actually move to somewhere to a website, so you can see it. But anyhow, if I want to type it on my screen, so I just move down here. If today you are new, first time, right? Anywhere on this actually notebook here is a place for you to work on. Yeah, for you to work on means that you can type in text as actually word processors. You can put in pictures, media files, just like how you do presentation with PowerPoint, or you can type in any actually interpretable input for system to do computations. So for instance, now I want to put in something that I put double equals. I don't have to do that. This is something which we already showed it. Yeah, we already showed it many times before already. But now, in case your first time today, to let you know what's happening, So now, when I key in this double equal sign, I'm telling the system I key in some natural language scripting. Just like that I'm doing this thing for first time. I don't know what I'm trying to do. So I just type in this thing. So I ask the system to interpret for me. So I say solve 3x plus 4. Let me type it. Oh, okay, there being some. Let me retype it. The system will try to interpret what I'm trying to do, yeah, and convert it into internal symbols or codes that I can understand. So it will come up with a step-by-step explanation how it derive the solutions. So either it give me a solution right away, or it give me some of the graphical representation, so I can have better understanding. Of course, this is like primary school solution. Primary school algebra lah. So it's nothing much. Then we click on that step by step. It show you all the solution that you're interested to find out how to manage to solve this. Now, this is very invaluable, very invaluable. Now, the thing we put here is an oversimplified question, so everyone from different walks of life can understand what we are trying to show here. There's something much more complex, yeah? So this way, if you have free time, then we can actually further click on that, and you can put something that actually much more challenging. The system can show up accordingly. Other things, for instance, here now, earthquake in Indonesia in August 2018. Yeah, and you put in here, you show you all the big and small earthquake with different record scale in tabulated form. So some, of course, after some of you that attended a class still been arguing, a normal, ordinary, actually, information like that I also can get. But Wolfram actually allow us to access of terabyte of data, which is with proven source. Meaning some Wolfram will not simply crawl the internet to get us data of pictures randomly from certain search engine and try to compile it as if intelligently for us. No, Wolfram is responsible for the source data I get for us. Now, for instance here, if I try to get things something as simple as say, hey, tell me about Earth, Pluto, and Mars. Yeah. So now, if I do things like that, right, it does not actually go simply randomly access certain pictures or some of the informations from certain website and try to actually compile that and make it like looking nicer. The job of Wolfram is not to make it nicer only, but you have to do three things. First thing, you have to be output in a tabulated standard format. Tabulated means that you look at tabulated form like this. Second thing is you see all the actually you display unique measurements. They all are standardized. They're uniform and standard. This is first thing they do. Second thing is all the data here, whatever you output, can be used for input for direct consumptions. Yeah. So this is not like simply pulling data from here and there and putting here. No, it can be just for display, or no, it's not for display only. It can be used for direct consumption. I can actually ask Wolfram to give a particular part of data only that I'm interested in, then I use it for my further processing. Thirdly, of course, that this whole data, like say, it comes from a proven source verified by Wolfram. So Wolfram will not simply say, oh, I take from a first search listing from Google engine that I put together here, or here you are. No, it's not something like a secretary or putting together by simply look at the website of all hotels and give you. No, it's not like that. You're always coming from a trusted source. Who are my trusted source? And publish with a trusted source that I can even confidently give you a citation. So these three things that make the major distinctions. Now, in this case here, like it gives us comparisons with the Pluto's, these are Earth, Mars, and Earth. Yeah, make it smaller. see, it show according to the size. It's like too small to show this. Like can't really compare it graphically. What is the size is like a bit far too off. And immediately, again, all the pictures here, they are coming from a certain source that you can cite if you want to find out where it's coming from. Now, to further look at, before we go into like hands-on in a short while, 5 minutes time. Now, I like to point out in a quick conclusion here. Now you say, hey, these are programming extensions. Peter used a term extension, yet I use a term sometimes interchangeably about scripting. Okay, what's our difference? Yes, we can call this, sometimes we can call Wolfram language, yes, it's a coding language, or it's a programming language, or more my preference, I sometimes call it scripting language, but not everyone actually are familiar with this term. Scripting actually particularly refer to, yes, scripting is programming language, but it's more actually precisely referring to something like easy to then rewrite because it could be interpreted. Interpreted means that it's just like Python and R. You do not have to compile like a C, C++, some other programming language that you have to actually compile it into executable code in order to run it. No, these like Python, R, and Wolfram, these are language that we call scripting. But compared to Python and R, Wolfram is something that much in higher level. Higher level means that that's something more difficult. Higher level means it's closer to human being. That means high. Lower means that it's so low, like away from ordinary human life, like machine language. So when I say very high, that means it's closer to human natural language. It's very high level. So the higher it is, it's less code intensive. Now, programming is very code intensive. You have to do a lot of declaration. You have to be really a serious programmer. You have to be concerned with a lot of things that you have, unless you get trained as computer science practitioner. Otherwise, it's not something easy for you to master and go there. But again, many of us, we are maybe coming from the background engineering, applied science. Our major concern is how do we get a result that we want. Maybe we can even develop our solutions solver into tools that everyone can use. We are one to rely on something less cost intensive, so that we can actually achieve our result and in a way that we want it, as we want it. Now, if you look at this whole thing, this super computational book, everything actually fit together. This now ever growing, now up to 7,000 building functions already, covers so many different aspects of solutions. And we have actually things like how do we do image processing, computer visions. We have particular one complete actually library devoted to graphs and networks, even to media files, sounds, sound processing, geometry, time series or time related computations. And we have entire sections actually devoted to geographical data and computations. Financial data and computation is a financial data. What does it mean? Yes, all kind of financial computations, stock market, like all the visualization tools, all the forecast tools, and some of the special tools that use for people do calculate financial derivatives. Everything's out there. I'm coming from this field of experts, social and cultural linguistic, and some are higher computation power. Now, something worth mentioning here. This is something like not actually many so-called off-the-shelf software provide. Now, this is something like quite remarkable because Wolfram provide actually whenever you do computations, right? Usually, if you try to trigger serious computations, they are actually compute one after another using one of your CPU, either the CPU core or one of the CPU thread. Wolfram allow us to drive 8 cores in parallel, meaning is that with a simple chain of few codes, you can actually parallelize the computation. Say, hey, let's say my computer is like I have 2 CPU or quad core, all together. Theoretically, I could have 8 cores. I can drive it. So I can actually run my computation simultaneously on 8 cores. Yeah, otherwise that maybe one core is used by PowerPoint, one core is Outlook, one core is by Google Chrome. Now you can actually assign maybe 3 out of 8 cores actually want to run Mathematica or Wolfram computation simultaneously. So I can actually achieve result 3 times faster, theoretically speaking. So this is something that is quite remarkable. It's built in easily and also allow you to run on the GPU. Yeah, and to write CUDA actually language or even sometimes without CUDA language, Wolfram can even allow you to access some time for some GPU computation directly. This is something very, very powerful if you actually are thirst for some computation power. Now, we will take 5 minutes break so that everyone will get ready with a file so that we will start going on some hands-on for the next 1.5 hours. So everyone buckles up and we shall resume in 5 minutes time. Yeah. So by the time I hope that you have all the files ready, then you start from this slide 14 onward. So everyone can go on with a nice and easy pace. Then you walk away with something that surprises after the class. Yes, see you in 5 minutes time. Okay, let's get ready in 30 seconds. There's no password required for, after you download, it does not require password to open it. Just open right away. Thank you for asking this. Now, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Welcome back. Okay then. Now, let's come back to slide 14. Yeah. Now, today I only teach you, or rather, I think some of you have been a user. I see some of the names actually I feel familiar with. I think so. So Wolfram might not be something that entirely new to you. Yeah. But either like say you have been users or you're new, today only trying to emphasize or refresh three things only. First thing, how do we define variables? Yeah, in Wolfram. Is what's a basic rule of thumb. Secondly, how do we handle data? This is very crucial and important. Wolfram, of course, have many ways to handle data in different situations. But if you actually understand the fundamental one, the most important one, and the rest of things is just further built on upon, it's very easy already. Thirdly, how to make use of so-called pure functions in Wolfram. Allow us to do iteration. Doing iteration means looping is very essential for any programming. Yeah, for us, why programming could be fast and easier because it can loop and repeat tasks easily. The repetition is an important thing why we want to do programming. So Wolfram do not perform the traditional procedural programming looping. Yes, of course, you can use traditional programming to do that using Wolfram style. Yeah, but Wolfram, the reason we come up more and more functions is it already have pre-optimized a lot of algorithm. So we do not have to rewrite or recreate our own. But yet, sometimes when we have deal with data, especially for instance, you want to perform design experiment, you have a serious data want to fit in, you want to do things repeatedly, you want to do things in iteration, then using pure function or some iterator in Wolfram to understand basic way of doing this thing is very, very crucial. So three things. First thing is about variable. Second thing is about handle data. Third thing, I'll teach you how to use pure functions to do iteration very quickly. Yeah, these three things. Yeah. So now, first thing we look at slide 14. Slide 14 here. This is of course is not something so-called something you must abide with, but there are certain things that, for instance, our preference. And if we speak to some of the Wolfram practitioner out there, and you notice that this is some of the common actually style we use. Usually that in my preference is, I usually define my variable like this. This is something called camera style. The first actually in Wolfram user-defined variables, that means you want to define your own variables. The variable, the first letter has to be lower cap. Because Wolfram have 7,000 functions, each function, the first letter always upper cap, or means capital letter. So to differentiate your own variables, user-defined variables, or your own function, either you call function is, or your own variable is user-defined function or user-defined variable. The first letter always makes it to be lower cap. So Wolfram, then you can tell, oh, this is something I define my own, nothing to do with the system one. So in order to further leg extend how I usually put mine in front, then followed by the desired variable name. Then the variable is itself followed by equal sign, equal to John, or equal to object, equal to what a symbolic object like image, media files, expressions, numeric number, vector numeric, anything, any sort of that. Now, another type here called Pascal style. Yeah, this is not acceptable in Wolfram. So we cannot do this. You cannot make it like say the first letter, capital letter, is reserved for system functions. They are one of the 7,000 functions. Now, again, the snake style, some of preference, or sometimes we put underscore. Yeah, In Wolfram does not accept underscore also. So remember two things. Make sure your first letter always lower cap. Make sure if you want to break actually your multiple words inside a variable, do not use underscore or some other breaker. Just use difference, actually cap the differentiated. This is how we approach. Use camel styles. Why is it called camel? Yeah, do have to know like this is how programmers name it. Yeah, they only have to know this is how we name it. Now, this first thing about variable. Second thing is the list. List is when it's called list, right? In earlier time, people always call array, meaning that it's a place that you hold data. Yeah, you can hold data internally inside Wolfram by telling that whatever in between this curly bracket are the data that I wanted to keep. Yeah, so inside here you could see inside between this curly bracket, in between this curly bracket, I can keep actually not just numeric number or string like traditional array. I can keep actually things like, see this one X is like in purple color. This is some system recognize it as a symbol. Symbol means that is do not look at it as a character or string. You look at it as an object. Often thought, oh, this X can represent a variable. It could represent a object somewhere. And also itself could be like this one here. It could be entire expressions. Or inside there could be another list inside a list. Or that even like this one is a rotatable, actually 3D object. So these entire things like could be actually how by putting in between two curly brackets. So system know this is something a list of data I'm holding. Now you look at here like function here like I can put in strings. I can have another color here. If you move your mouse to this particular object here, you could see this one actually itself also is object. I can even adjust the color it right away on the screen. So you say, hey, how come it's like that? Yes, this is how powerful it is. You're not looking at things like just like something copy and paste from somewhere. Wolfram accept all those things almost like all kind of different objects inside is data holding place. We call list. Yeah. So even I put my pictures here. So now knowing that you can do this, right? The next thing is if you want to find out retrieve back certain particular value from this list, how do I do? For instance, you notice about this one here, this one, right? If I count this particular one from curly bracket to curly bracket, let's look at here, curly bracket, and if you see how many actually number of elements inside here or how many objects inside is 1, 2, 3, 4, 5, 6, 7. So altogether are 7. So now, if I tell the system, I say, now, I'm only interested in getting the data out from the third one. Let's say I want to get Noraini. The rest I do not want. How do I get Noraini? So now, if you run this one, right, by hitting Shift-Enter, the system will execute it. Execution actually performs some computation, but because we do not ask any operation to be performed on this list, whatever you put in input as output. So I have in 13, out 13 now. So this is my input 13, actually perform some computation already, but we did not ask it to do any operation explicitly. So what I get in, out 13, they're exactly the same thing. But now I say, hey, please don't give me all the output. I'm interested only getting Noraini. So now, if I want to tell system which one to give, we always use this thing double square bracket to control it. See, if I type this thing, right, I type this particular square bracket, I type left square bracket one time, the system will try to fill up with the right square bracket, try to complete for me automatically. Wolfram come up with a lot of reason for automatic completion. It's very handy. But now if I type one more time, left square bracket, you also auto fill up another right square bracket. So that means that I only have to hit my key left square button 2 times. you will auto fill up the right square button automatically like this. So I say I only interested on third one. So if I put a third one, right, now you notice here the output become Noraini, because I say now I have this entire list. I want you to give me only a third position. Yeah, so it return me the output, it perform operation, say, oh, extract the element on the third position. So similarly, if I say, what if I want it to be the fourth positions, become science? What if I the fifth positions become 1? So it gives like that. So now, you knowing that we can actually easily access to any position of the data that we want contained inside list, then in regards to list size, how complicated the lists are. We could have list inside list, inside list, and inside list. We can actually use this thing to use this simple square, double square bracket with the position number to exactly pinpoint a certain data that we want. Of course, list is one of the at least 3 ways. There are 3 ways to handle data efficiently from. Another 2 way is one is called association. The way is called data set. These are actually a design for us to handle actually big data efficiently. But for normal data actually handling, this actually list is very sufficient already. Now, if I want to look at here, I say, hey, what if I put -2? -2 means I want to count the position from behind. Yeah, 2 and 6. So I count from behind. That means I want to do the position counting reversely. So yeah, -2, then you give me like 6. If I want to give it a count from reversely position number 4, then you give me like sin x. So this is how we can count from left to right. And again, another very convenient way or common way of doing is I want to do the spanning. Spanning means that I want to system output from Noraini all the way to 1. That means that Noraini is, Noraini, not from Noraini, from here, position 2 to Noraini, all the way sine x is to position 4. I'm only interested in these 3 elements inside. So I can put 2 semicolon, semicolon 4. That means that you give me like this. So again, say, Peter, 2 to 4. What if I only want 2, 4, and 5? Yeah, I don't want 3. Can I do this? Yes, of course, there are more actually slightly advanced control. For instance, I can do like that. I put now a square bracket inside. Yeah, now I want to move control. Yeah, not square bracket, it's curly bracket inside. I say I want it 2, comma, then 3 I do not want. I only interested 4 and 5. Now the system give me the element on the position of 2, 4, and 5. So now you say, hey Peter, how come now you're putting in one more is another curly bracket inside the square. Curly bracket is not just help us to hold actually data inside a list. You also can hold all the actually element, like say element, not necessarily data. This element represent parameter. Yeah, I'm holding a series of let me take another of 0. Thank you. Now, this curly bracket simply means that now holding a parameter represent position 2, 4, and 5. Because if I put 2 double semicolon to 5, it know actually is 2, 3, 4, 5. But I want to specify only 3 things. So I will put curly bracket to tell the system there are 3 input parameters here. So the same logic goes like that. Some other useful operations. This one is inside here. I have these things now. I define, you see here, I start putting what we learned just now previously on the current variable. I call something called my list. So you can put, you see here, this my list, I start again, lower cap. I mentioned before this row, my list. I say I could have my list 01, 02, 03. Usually is my preference because I could have using this thing, the same approach to represent the list. So I have 01, 02, so I differentiate it. So I say, okay, this whole thing actually is my list. And again, behind here, put semicolon. I suppress output. So I hit this thing, shift enter. Now, the moment I run this thing, right, you notice my list become to black color. Previously, before running, it's different colors, blue color. So it turned to black color means that the system understands it. This user-defined variable is already actually sent to my memory. It already has this information. So now, these are 2 helpful actually little functions here. First thing is to check on length. I want to know the size of my actually. So they tell, oh, inside this list, I have 7 elements inside. So you could have actually list holding like 10 or 1,000 records or different elements. This is very common in Wolfram project, very common. I've been doing actually projects that holding up to like few millions of elements. You can create your own internal database or link to external database. So you are using this way to calculate how many actually elements inside and how do we perform certain operation accordingly. Now, we also can do some counting here. I say, hey, I want to do counting. How many elements they are same, they could be put together, same category. So they are some basic operation. Of course, length is commonly used, counts like there are some other function that's available for us to play with. Again, you say, what are some other functions that I can play with? You can always, for instance, here, the system always give you a recommendation that you can always learn from, that some perform similar actually purposes or something related. For instance, if I highlight this thing, right, I say, hey, I highlight this length, I check on something called get help. There are several ways of opening this help file. Yeah, a lot of time we type it, the system will try to autofill for us and also will ask us, would you actually want me to give you a help file or not? Yeah, if not, I just simply either hit F1 or select get help. You see down here, right, in this particular actually help menu, it gives us actually a lot of example and also tell us that what's applications, how you can actually apply it. In some important application that even sometimes we come up with the importance reference and tutorial, even sometimes give you some historical background, especially if the function have to do with some certain theory related kind of things, theorem related. So we tell that what you have to watch out, things like that. Now you see down here the system is saying, hey, if you are interested in counting, maybe you're interested in something called leaf count, byte count, dimensions count, depth count, string length count, atom queue count. This is something that we're going to use later. Yeah, complexity function, length y, count distinct, check arguments. Hey, say what are those things that sound interesting? Maybe you will find immediately, oh, here's something actually I'll need to use it also because I really want to perform some counting. Now, there are many ways. But let's quickly look at what we could further achieve. Now, we have some basic understanding about 2 things already. Yeah, about variable. Second thing about how we actually use list to handle data. Very basic way, but cukup enough already. The third thing is not very important already. We want to perform iteration, like say looping. How do we do things repetitively? Now, doing looping repetitively, first there's about 1 or 2 functions. You should have to go play hand in hand with pure function. I'll explain pure function later. But before even you come to pure function, the first step are iterations, right? There are certain functions can help us do iteration already. First one is called table. Table doesn't mean that to come out with a jadwal or something like that, or come out with a tabulated table. Table means that it try to tablize your expressions based on the input of value accordingly. Now, For instance, in this case here, I say I have x squared. I say, can you tableize x squared in terms of x starting from 0 with increment of 1 to 10. So this is like very oversimplified actually expressions. We did not define increment, we did not define initial value, we just say that the end value is 10. So if you run this thing immediately, so oh, this one, you see, it start from x is 0, then x is 1, then x is 2, x is 3, 4, 5, 6, 7, 8, 9, 10, all the way like this. Yeah. So you could see that actually it go on. Yeah. Starting from, sorry, not from 0, starting from 1, the increment start from initial value 1, the default increment is 1. So immediately it helps us repeatedly in another way, or in other words, you repeatedly run x squared with a series of input based on x starting from 1 and to 10. So table is a quick way for us to repeatedly perform all the same expressions with different input. We use this. So if you have an expression, we have multiple input, right? You want to quickly actually run, especially the input is in a running number. Yeah, you can quickly do this. Another way is like using range. Range also is another way for us to quickly actually do things in a series of increment manner. Now, in this case here, I have range. Range, for instance, here, if I put like this, right, range 10, if I run, it simply expand out range from 1 to 10. Range do not give us actually a choice to define the increment. Now, step increment. Now, I keep on saying step increment means like this. For instance, here, x now is 10, right? If I put it here 2, I say x start from 10 and by start from 1 and by 10 the increment 2. So the system each time, right, it know it start from minimum number 1, the maximum number 10, each time increment by 2, or I say increment by 3. Yeah, okay, increment by 5. Yeah, this is what we get. But for range, on the other hand, you do not have choice to configure the increment. It's simply like running 1 to 10. Yeah. So if you want to, for instance, here I say, hey, in this case, it's convenient. Say no, I simply want to make it be like all the running number actually to power 3. Then Peter, you say, what's a good use of this? Yeah, what's a good use? The good use are manifold. Especially today, right? If you have actually a series of data, let's say 500 data inside the list. You want this 500 data list, right, to be actually consistent run for each of them. That means 500 times. So you want to tell the system run 500 times. In the past, right, usually what we do in the structured programming, we say, oh, please do loop while this whole thing is less than 500. Yeah? But in Wolfram will be a different way. Wolfram, in this case, usually what we will do is to say, hey, I try first thing, find out what's the size of my data size. Yeah. If I want to find out what's the size of data size, for instance here, let's say I randomize random number. I say give me a random number of Hi, it's not random real. Okay, you say I generate a random number from 0 to 10 for 20 of them. What if now I want to generate 200? Yeah, it's 200. But if I put this dynamic column here, if I do not even see this thing, I do not know actually there's 200 inside. I can say my number. You do not have to type this. This is for conceptualize only. Now, then I say, can you tell me what's the size of my number just generated or not? Then the system say, oh, it's 200. If at 200 right now, if I want to perform actually computations of this particular set of 200 randomized number, right? Like I say traditionally, I'll do loop while it's less than 200. So then in Wolfram here, what usually we do is we say, now we do not do something like do loop while it's less than 200. We simply say its range length is 200. Then I say, please do this thing in a sequential manner, 1 all the way to 200 times. Yeah, this is what I'll do. Say, hey, Peter, we're talking about, give you like simply output 200 number. Why we are doing this? Now, later on when we introduce the pure function, this one will come to a very clear picture. Why using this length and range together, how come can make our looping so much efficient and very powerful? This is one of the common actually approaches I can never live without when I'm doing any commercialization project. Now, let's first look in here. Taking this example. Let's say we want to do some like molecule. Say, how come we are doing this molecule? This is not chemistry class. Now, this is something like our scholar mendengar a very basic chemistry when we first given this introductory about molecule, so everyone can understand. In Wolfram, we have many actually things built in like that. Yeah. Later on, I'm going to tell you there's something called, like I say, Desmond had shown to you last week about curated data. I'm talking about terabyte of data out there. Yeah. Like I say, Wolfram also have huge number of actually gigabyte data built in without you have to download from internet. It's already there. But of course, certain packages are actually left really not really updated all the time. Only the moment you want to use it, you try to re-download and update one more time for latest information. A lot of the information are also pre-installed and built in. For instance, this thing, caffeine, when I say molecule structures. So Wolfram actually built in with tens of thousands of different compounds with the 3D molecule structure. Surprisingly, yeah, this thing make our life a whole lot easier. So I have this user-defined variable called my_mol. I say, give me molecule structures of this caffeine, or I spell out, it looks like that. If you want to visualize it further, we have something called molecule plot 3D molecule. This molecule caffeine, right? Say, hey, can you molecule plot 3D? Now, you don't need to actually memorize function only. I just let you know there are a lot actually. Each time actually you click on something, the system suggests you to do something else, yeah, along the way. Yeah. So for instance, here, the moment actually I do this part, right? If I turn on some wizard, the system will suggest that next time, do you want to actually look at these 3Ds? This 3D is not something I have to memorize and come up with. The system usually will give suggestions. You want to look at this thing along the way or not? Yeah, something like that. So this is something like not just good for visualizations, but for teaching aid is a very powerful tool. But let's say we're not doing teaching. We just say, okay, now see that we already see these thing 3D structures. The next thing is we want to perform iteration. Important thing here is not to visualize how beautiful they are. We still go back to what we're supposed to do, which are doing iteration. So what we want to do iteration in this particular part is we say, okay, now we have this thing, my_mol is a molecule of caffeine. Yeah, actually we know this molecule inside carbon, nitrogen, hydrogen, oxygen. But I say, can you give me this my_mol? Give me an atom list. I want to see the individuals atoms. What kind of atoms are there? Now, the output for us, see now you say we have nitrogen, carbons, oxygens, hydrogens, all together inside there. Now, After that, now we say, okay, see, now this is one of the very simple breakdowns or the atom compositions. Things could be much more complex, but this is like for our own understanding. Now, after that, we say good enough. We want to perform operation on the list. If you want to perform something that data will come, how do we perform actually in iterative way? Iterative. Now we haven't come to any iteration yet. We say, okay, let's do some tally. Now the system tally for us, say, oh, if I tally above this conclusion output, right? Now we could see that in fact we have 8 carbon, 4 nitrogens, 2 oxygens, 10 hydrogens. Okay, satisfied. Now let's move on. The next thing, let's say we calculate the size, some atomic weight later. And let's say we further go on. I say totally length how many? 24. Now we start doing this already. First thing I check. The length is totally 24. So 24 means that it's a combination of all these things. Yeah. I know my atom, if I tallied it, it breaks down like this. If I don't do any tally, I just say, give me a length. We say, oh, 24. There are 24 atoms inside. I don't care what they are. I know there are 24 atoms. So this is my length. Now, we start doing some iteration right now. Let me just zoom out the screen so you can see that how we come to this part. It's very important I make the screen tidy. I know many of you are not unfamiliar with Wolfram, I believe so. But sometimes I explain the concept on the screen when you're trying to work on your own notebook and look at the screen. If my screen getting too many display, it's not easy to catch up, yeah. So I want to make sure the screen is clear, yeah. So now, in this case here, there's another function called element data. Now, like I said, I've been throwing in a function like molecule function, block 3D cube, molecule function, and now element data. I say, Peter, you suddenly throwing a lot of chemistry later function. These are not important. Important is we try to illustrate to you how this iteration works. Yeah. So now, if I want to get atom number 3, I say atom number 3. Yeah. Inside here, there's several brackets right now. I'll explain this bracket later. So it tells us that atom number 3, right? The atomic weight the system knows is 12.00 mg. So now he say, hey, Peter, what is my atom bracket 3 and 1? Look at here, right? If you still remember previously, if I put that this my atom is simply like this. It give me everything, 24 of them, 24 atoms. I say I'm interested on atom number 3. Atom number 3 is what? Carbon. Number 3, third one on the list. But I say all these things you have atom and C. I say, hey, inside you have 2 parts. I'm not interested about you atom. Only interested about first part. Yeah, first part. I put 1. 1 give me C. Say, hey, Peter, if I don't put 1, what does it? You have 2 lah. The system actually will put in 1, right? This is some of the things sometimes we have to try out. I say, hey, I don't want the whole part. I just want the C symbol. So I say, okay, give me the 1. Inside it contains multiple parts. I say, give me particular part, that one. It give me C. So element data, I put my atom 3, 1, simply give me C. The system knows C is not normal capital letter C. It's referred to carbon. So it give me the atomic weight of carbon. Now, what if we want to extract atomic weight for all the elements on the list? Now we start doing iterations. We say now we want to do this thing over and over 24 times on each of them. Now this comes to the very important part. Now remember what we learned before is a table. Yeah, we're using table first. Table means like this case, first one, the expressions there, right? The first expressions. Expression is this element data atomic weight. But now you see here, I say I do not want to tell the system which atom want to extract from. So I put X. See, X is unknown. But I want X, right, is based on my length. My length is what? 24. So the system will run from 1, 2, 3, 4, 5, 6. We increment 1 until 24 repeatedly. Yeah. to run this particular function in the middle, element data, atomic weight. So this is how you perform normal iterations with the running number. So that's why I say using length is very useful, but I haven't come to range yet. Yeah, when you do this part, the system simply give me an iteration quickly using table. But this is one way. This is one way. So of course, I think after break time, after this class, you can sit down and digest it. And then you come, oh, this is actually so simple, and yet it's so convenient. Now, before we move on further on the iteration, yeah, I need to actually point out the reason why this whole actually repository knowledge base become so much useful in Wolfram is the built-in pure function that make iteration simple, so that all those data is easier for us to digest, ingest, and compute. Yeah. Otherwise, without proper good codings that perform iteration, a lot of data like this, right? We have to do a lot of post-processing. It's very difficult. But using all the built-in function plus the given built-in repository with the efficient way of doing iteration, computation makes so much simple already. Now, before that, this is like one glimpse of some of the built-in actually repository come during installation, not internet, no, during the actually installation, already inside. Yeah, most of them are already inside. Yeah. Now, when we want to know what's inside, right? This system here, in addition to the thing I showed to you, atom list la, molecule 3D la, a lot of things that the built-in. Wolfram has something called also entity. These are entities repository inside one. So if we want to see what are those actually built-in information available, if you run this one, it's called entity value, just double to run it, we see actually cover like huge number of primary classes of informations. Now, for instance here, right, there are several of them actually consist tremendous actually information like country. It knows so much about countries, all the world countries about information. Country is one main entity class. Inside there, there are subclass that, for instance, what are the ethnic groups inside this class? What is the populations? What is the gender ratio? What is actually GDP? What is actually agriculture export? What is import? What is the yearly deficit? And even the total length of transport highway? And what are the actually military expenses? All they have nearly about now 50 different subclasses of information about the country inside. Yeah. Also, like another thing is like even if you look at here book, this is also you say, hey Peter, what's books have to do inside? Amazingly, I last checked, inside Wolfram contain electronic copy books, English version only. Nearly consists about 10,000 copies inside. That means that it's already pre-installed inside. You can download, for instance, even Lord of the Rings, yeah, all 3 volumes, all inside. Yeah, you can actually pull out and do some analysis, read it, and it haven't included some other languages textbook inside. I think it contains at least another 20 over other languages of different classical books that actually it kept. So these are that much information inside. But now, we are not interested in talking about books here, but right now I say, hey, what about I look at something called here. You see here we have something called here. Let me try to point it out. Further down. Historical event, historical period. So these two are quite actually quite interesting also. Let's say we choose one of them. Yeah, we choose one of them. So now I just try to hide this thing first. Historical period. If I hit a historical period, right, it shows us this is all the historical period it knows about. You see, like say, historical period is one of the major classes. Inside they got so many subclasses. Subclasses got so many things. Like for instance, let's say if you are doing, let's say, Islamic history, for instance, one of the thing is that you're interested in knowing the Islamic golden age, yeah, like this part. And what does system know about that Islamic golden age? So what we have to do is I say, tell me what you know about Islamic golden age. You say, okay, you give me an output Islamic golden age, but this is object. This object inside hold something. Then we say, hey, what do you hold? And let me know. So in Wolfram, a lot of things that if you want to know what objects are holding, usually not all the time, usually 90%, you type in properties, right? The system will try to tell you that what's inside there. Now, the system now seems to know that, oh, inside this Islamic golden age, it know about 1, 2, 3, 6 informations. So I said, okay, these 6 informations, okay, I want the system to show it all to me. Say, fine. Seems like you know all this thing. I just paste back here. I say, now, don't tell me about properties right now. Just tell me actually, you say you know these 6 things, then please output for me. So immediately the system show all for Islamic golden age. The areas involved, these are countries covered, and the year is start and the year is ended. So things like that. But now, this of course is not, we don't talk about iterations, let you know a huge repository available, so you can perform a lot of iteration later, why it matters that much. Yeah. Otherwise, data is left without efficient way of processing, it's just like a job half done. Yeah. Now thing is how about external? External, I say that terabyte data, we find many ways of accessing external data, like even provide a lot of API to connect to, for instance, connect to LinkedIn, connect to Twitters, connect to Facebook. Now, there's not, for instance, here they have this directory access to Google Book Ngram data set. Ngram data set is people interested in doing research based on the publication between 1,500 to 2019. So far. This is one of Google Big Data project. Yeah, it's a Google text corpora, English, Chinese, French, German, Hebrew, Italian, Russians, and Spanish. So if you want interested to access in the past, actually in the human history, that in the past nearly about 500 years of literacies and some of the publication, non-publication, most of the things are actually recorded in Google Book and Ngram analysis data set are available. Now, you say, how do I access this thing? Now, of course, if you don't have Wolfram, you have other ways like very tedious. But Wolfram provide us immediately you type word frequency data. Yeah, of course, in front I put a common actually a visualization tool. I want to do a list plot based on time series in terms of date. I put date list plot. So if I put word frequency, right, I say in the past, my hometown I live, right, early time people call it Gelang. Yeah. Now without E call also Glang. Yeah. Then some in the early time people pronounce English Glang. So there are many ways of agent about this. So I want to know from 1960 onward, based on publication in a Google Ngram data set, do some people actually change the frequency or using it in a non-publication? So system actually access a Google Ngram data set and you extract the date accordingly for me. So obviously it seems like there are more people using consistently in 1960, the frequency using a word. Yeah, Glang is always higher than Gelang. Yeah, but also like Gelang is getting less and less and less this day, it's become actually word actually going to is going to phase out. Yeah. So in a lot of formal official publication, now Gelang without E actually is become something that more recognized, yeah, official recognized because it's official name right now. So similarly, if you want to look at things, say, I want to compare between TV, television, and or phone, telephone, mobile phone, cell phone, smartphone, since 1900. What are the publication actually come up with like that? You see, before that, phone are lesser known in 1940s. People don't talk much about phone. All of a sudden, the 1960, common use of phone are actually in the literatures are same thing like televisions as in early 1900s, the already terms of TV and television already. And now people don't talk much about that in particular. It's like compared to other keywords, there are more keywords more than that. Because compared frequency does not mean people are mentioning less. Is to say compared the amount of frequency of mentioning it among all the used terms, this is like getting less. That means it's like something getting either more common or something like getting lesser use. It's like up to you to further research upon. Now, a big sidetrack already. Now, we end with the last 30 minutes strongly. Now, we have actually further emphasized now how to reduce iteration efficiently with one or two more things before we come to pure functions. Now, one thing for iteration, just now we introduced about table. Yeah. You use common expressions, map over common expressions, run it with a series or running number. But map is this case here. Now, what if it's not a series number? A lot of times, like not series number, because we might have input is like 1, 3, 5, 7, 9. Then immediately jump to 20 or any number we want in the list. We do not want to be like be an input, be a proper running number. The input might not be a running number. Yeah. So this time we use a map. So now, for instance, in this case, how do we use map? Map simply means that map has short form. This is something that you will see very commonly. If you go to any Wolfram site or any Wolfram user site, almost all users of Wolframs, experienced one, they always use this /add. /add means map. Map means, for instance, in this case here, right, my input here is 0.1 pi radian, 0.2, 0.3, 0.5, 0.5. So for instance, I might not necessarily want to follow this manner. What if I say, hey, this one, I want to suddenly change to 0.35. This one, I make it 4.1. And this one, 1.3. Can it be like that? So I want this size, yes, this size, right, with an input based on this 5 element inside this list. So I have this list behind as my input parameter. So I say this is the expressions I want to map with this input. So if it's like perform a series design experiment. Design experiment means in this case, when this oversimplified expression is signed right now, I experiment with 5 input or radian. Yeah. So this 5 input radians like that. It's no longer a running number. Yeah, previously we could have running numbers, say a table size over something. Now, if we can recall, normal way, if ideal way, I say, oh, table, yeah, table what? Table sign. I have the table sign what? X, then with X what? X is a running number for what? From radian of 1 to 10. So it quite likely give you like this. Now, of course, you say, oh, I don't want to be like that. Yeah, I want to be like, start with 1 radian. So I put radian, and let me switch to pi. Yeah, and each time I want to start with 2 radian, 2 pi radian. Let's make it to be 2.1. Yeah. So it becomes like, this is ideal when perform iteration, when things actually can control in a running in a sequential manner. But in this case, it's not sequential. It's just like any user parameter input I want to throw in. So that's why map becomes so much important. and flexible and useful. So now we know we can use map to do an iteration like that. The next thing we look at here, let's say we look at our actually solar system. Now, our solar system here, we also is using entity value. Say, hey, this entity value, we look at here, we skip the first part. We say planet, give me a name of all the planets inside our solar system. So now we have 8 planets here available. Now I say, can you please actually show it to me, all the planets in terms of number of moons, the mass and radius and gravity. So now if I actually create actually another you see here, these things here, this is called, if I run like this, right? The system, it would simply show me a list output. So this is like entity value. I say, give me the moon count for all the planets, the mass value for all the planets, the radius for all the planets, and gravity of all planets. You see here, I ask the system give me actually 4 output in one go. Now inside here, right? Now this is the interesting part already. When I want this 4 outputs simultaneously, of course I can ask the system give me output one by one, like this one, planet name. But now no, I say give me moon count. Immediately I say I put a comma sign there. I say now after that give me mass. I put comma here again. I say after that give me radius. I put comma again. And give me gravitational force. Yeah. Now no more comma, but I wrap up this whole thing with the curly bracket. So system know actually I want 4 outputs same time. So if 4 outputs same time here, right? It becomes interesting output like that. You have multiple curly bracket. Now this is something called list inside list. It's interesting and also powerful. Might not be actually that easy to view in our naked eyes, but let me highlight one by one. Hold on to horses, then you see it makes sense. This is first list, yeah. This is second list. Let me color code it. This is third list, which is the radius. And the final list, the gravitational force. Yeah. So system now, you see here, they have each of lists here also now is covered with one actually curly bracket. But outside that, there's one major curly bracket to close the whole thing. So now, in this case, I have this entire user-defined variables called my planet, which is up there, that will contain the information down here. Yeah, this whole, whenever I call my planets, I'll have this actually 4 sublists inside a list. So now, what if I want to iterate a function over there? What does mean I want to iterate function? Now let me just close this part. I say, now, I want to get a max value. Among these 4 of them, right? You see, if I put here my planets, yeah, I run this thing, it always give me back this one. I say, now, I don't want to look at all those things, yeah, like the radius, mass, and gravity. I only want to know the moons, yeah. So now, the moon actually is, inside is the first sublist of all the 4 sublists inside the main list. Yeah. So to retrieve the first sublist, I put 1, so give me all the moon info. So what if I want a second sublist of the 4 sublists inside the main list? So this is my mass. So and then I say give me a third sublist and a 4th sublist. Yeah. Accordingly. So again, I say now, if I go back to the first sublist, right? I say, can you give me the maximum number? So maximum number, I want to know what's the maximum number of moon we have. So these are maximum functions. Yeah, 83 moons. Yeah. So I say, then what if I want, what's the maximum planet? The planet with the heaviest one, yeah, in terms of mass. Yeah, you say this number. Then I say, give me a maximum number of radius. This one. Then give me the amount of the planet, say planet which the higher gravitational force is how much. Yeah. Yeah. this 24.79, yeah, is almost like two and a half times than Earth. Yeah. So then I say, I don't want to go through one by one. Can I immediately give all the maximum number and everything? So in this case, immediately we can use map function already. I say among all these 4 sublists, yeah, I want all the 4 sublists is my input. And then I want to perform this max over each of sublists one by one. So in this case, what we have to do is we use this map over all the available, actually availability inside. The system immediately actually will step through each of them automatically. That means that inside the main list, we have 4 elements. Each of 4 elements that we perform the max function, be sublist 1, sublist 2, sublist 3, sublist 4. So this iteration now quickly perform like that. Yeah, this is very simple example. So immediately give me and all the information I want, just like that. But now, if let's look at something like much more quickly. I skip this part. Yeah, procedural programming is nothing, no big deal. Yeah, like I say, procedural programming is lower level way. Usually, if you are a serious programmer, yeah, you keep on doing that. Wolfram allow you to do that, but Wolfram actually will encourage us to use the built-in function as much as possible. It's efficient. Why is that so? Now, like I say, we skip this part first. Later, we give a quick review about big O notation. Now, so far what we learned about variable, list, table, range, and map. Now, these big O notations, like if you're a computer science students, 101, right? Your class will explain about this already. It's simply a way how we denote the complexity of time and space. Yeah, time means that computation time, space is how much storage or memory take up. If you are born in 80s, right, you maybe still remember quite well about millennium bug, things like, well, whole world thoughts that it's going to come to the end of the world. Why? Because computer design early 40s, people want to save space. So the totals get assigned for the counting number date, right? It run out in years 2000. So people thought a lot of things get reset now. So we have spent money in the computers and to make sure it's millennium compatible. So things like this could be one big issue. So now, but we today, like I say, we are actually we want to be a problem solver. We not all of us need to be trained to be a coder. So this part is still important, but we let actually expert to worry about that. So proprietary software should handle this thing properly. I give you one example here. For instance, if we're talking about some of the sorting, there are like few hundred sorting algorithms out there in the world. Yeah, like talking about normal sorting, right? We already know, I think it's 100 over already. So our first year in college time, we go coding 101, or the first thing they teach you do bubble sort law. How to do merge sort. Your lecturer sure ask you to do some time sort, merge sort, bucket sort, ask you to compare which are more efficient. But we know even a thing as simple as sorting we have been taking for granted, they are actually different complexity, in terms of time and space. Some, like for instance, the things that easier to understand, bubble sort, might not be the best performing one. Yeah, because actually they are much more efficient one, like so-called bucket sort. Actually, it can even perform better. But now, the reason I point out this thing is, if we say now, as long as we can solve a problem, computer this day is fast enough. What's a big deal? Oh, the big deal is very big. Yeah, and give you one example here. For instance, here, this is like slightly older computer, like computer. Let's say you bought, let's say 5 years ago. Wow, this day quite thorough. Even I think the inflation and everything, I find a lot of recon computer there. I feel like the time travel back five years ago. A lot of low-end CPU now appear in the market. 64-bit dual core, 1.5 gigs Celeron CPU. Yes, we see here, like if we perform a computations, right, like some of those things, there are some that are so-called, when we perform big O notations, we look at how the complexity, right, certain things that how we solve the problem size depend the complexity. Like normal complexity is like this one. Things are like really a big complex one, like this one. Right? You say, hey, I perform actually the problem size 10, right? Oh, very fast, no problem. If you perform like up to like 100,000, right? It take 17 minutes. 17 minutes is not much, but 17 minutes in this case, you're talking about nearly maybe 20 seconds. Yeah, nearly 20 seconds, you can't really wait on 20 seconds. You keep clicking thing without the system not responding. If things are far worse, like 2 power to n, yeah, if compared to the sample size of 10 and the sample size of 100, it can mean between seconds and years. You say, could it be? Yeah, it could. Let me show you one example here. So if you look at the ordinary programming tree algorithm, right? People ask you compute Fibonacci number. Fibonacci number, exactly the way you follow textbook to program it, right? Is n to the power 2 to the power n, the complexity. This is how the recursive calculation of Fibonacci number works. So if you look at the calculator, first is 0, then followed by 0, 0 plus 1, you get 1, then 1 plus 1, get 2, 2 plus 1, get 3, 3 plus 2, you get 5, 5 plus 3, you get 8, and 8 plus 3, you get 13. You say, even human calculation can do how complex, but this whole actually algorithm is 2 to the power n. Yeah, of course, there's other smarter way to handle this, but proper normal human being thinking is n to the power n. 2 to the power n. So the more, if you go above, right, come to like 30, it's remarkable already. So to prove to you, right, if you go any textbook, you see this is a Fibonacci number actually algorithm. It looks like quite simple like that. It's simple functions. So now if you try to say I want Fibonacci number 30, right, you run this thing, you watch out, you have to wait for about I think about 3 seconds. Not long, 3 seconds. But now, let's say you no need to do this. Wolfram have one actually function called absolute time. Absolute timing. So the system will keep track, right? How many seconds actually it takes from calculate Fibonacci number up to 30. So about my one about 3 seconds, and now 6 seconds, 6 seconds, 3. Now, what if I change to 32? Now it take much of it, 30, 32. Yeah, it's like taking a whole lot of time to calculate already. Now it's 15 seconds. So I dare not actually touch anything above 35. Yeah, if I touch 35, I think nearly sometime to 45 seconds to 1 minute, about that. So if we go to like 40, right, it may take I think few minutes to calculate. Now, if you look at actually some of the built-in functions, right, I say Fibonacci number 35. Wolfram built-in optimize actually functions to handle. It doesn't go through the normal actually how we design the algorithm. Immediately, I say, what if give me 335? The output split. If you run 355 using this algorithm, it's going to run years. Yeah, to get result. Trust me, I'm not exaggerating. So now the reason I'm saying this thing is Wolfram allows us to focus to use this function available to perform iteration very quickly. So we don't need to worry about too much to go to low level procedural programming. Now let's start using pure function to close this entire class for statistical programming. Like I said today, I only let you learn 3 things importantly. First thing, very basic, we handle variables. Second thing is handle data using lists. Yeah, at least you know how to extract the desired data from the desired position. Third one, how to do iteration using some basic functions like table, range, map, and together pure function perform iterations efficiently. Now, pure function actually is not common term people use. They say function will call pure function. This is the terminology used from here. It means that you can look at that itself as it's like X. Yeah, it's an X, but we put a hash key there. So the hash key there, for instance, here, this hash key, right? You can put without one hash, right? Hash is a hash. Now, beside this pure function, always have to come with this X sign, S sign. You say why S sign? When you look at SI system, no, this is a pure function. So this X is is 50. Yeah, you say whatever this hash you try and deal with, right? Please take it from behind. After behind what? Behind this and symbol, then you give me 50. So same thing here. If I put in this hash, and you say, St. Peter, you can represent this one. The hash is hash. Can I put a hash 3? Yeah, can. Because you say it's a function, yeah, correct. This slot 3 in 3 cannot be filled. It's because here I only have one actually function, one function. But I put one can, just one can. That means that you allow you to enter like hash 1, hash 2, hash 3, hash 4. Multiple hash to represent many different input parameters as a functions. Yeah, are bit difficult to actually digest in beginning, but hold on to the horses. Now, let's say hash, I do not put 1. I hash just plus 1, come 51. Let's say hash plus 1, but now hash is not the plus 1 with which is 50. I want to map it over with the series of input 50, 60, 70. Let's say this one I change to be like arbitrary number 86, become 51. So that means that actually, if today I have a particular expression out there with a certain input I want the system to help me to fill up. So I can quickly use this actually hash key to represent as my input map over. Now, previously, for instance, here, for instance here, right, I have something called this one. Now I say this is the power. Let's say we make it to be square. So this is like slightly more complex as square. Now, map over see 50, 60, 70, 86 become like that. Yeah. So this is now, you start to imagine, oh, this could be a very complicated expression. We hash taking parameter from behind. So we can perform a repetition now very quickly already. So using this example, that this planet repository. So now we look at this whole thing. Example number 1. Example number 1 here, I say entity planet. Yeah, entity planet. Now, I'm interested in getting the mass only. But planet, which planet, I do not say. Yeah, but I say map over Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Uranus, Neptune. So the system now will give me output like this. Of course, it give me back all together, same things, all the mass. But now, let's say, for instance, I'm only interested on 5 planets only. I just take out the rest. So system show me 5. So I can control it, my input, I can control my expression. With this hash sign very easily. Same thing with this equation. They say, oh, okay, now this is like some random number. If I want to put some random number and anything I like. Yeah, and some other things like size, and I want to map over with a range of 100. This can quickly actually map over. So now, if we can do this thing, we can perform a lot of interesting example already. Now, in this case here, I extracted the world prominent leaders, not this year, 2 years ago. This is their pictures, my pick. Later on, let's say I say I have five faces. These are some computer visions. Don't ignore it. The simple functions are computer vision, 5 faces. Then the important part is later on we want to using one looping, right, to help us automatically loop through certain things to extract individual faces. Now, the system managed to extract, yeah, based on the coordinate, extract coordinate. I say, okay, trim out coordinate. The system trim out all the faces automatically. Say fine. Now you get trimmed out. Now after that, I say, okay, classify the facial expressions, about the emotion, things like that. These are some of the quite interesting little actually function for computer visions. But today we are not here to talk about computer visions, but it just simply go through, extract all the faces, try and analyze the emotions, things like that. But what if we put this all thing, these 3 lines of code, into a traditional subroutine? Yeah, because we talk about essential programming, some of you might start asking, hey, Peter, been showing things line by line. What if I want to put it together as one subroutine? How do I do that? How do I do a subroutine? So to do subroutine, right, you see here now we start putting in a one subroutine or create one function. This function is very simple. Say, I want this function, this computer vision called 5-face. This 5-face previously is the picture input. But I put X, I say my input I do not know. After I find a picture input, right, this my face recognize, I want an image trim. Yeah, same thing. You see, these 2 lines of code is exactly coming from here. 5-face image trim. Yeah, I run it 2 times, right? One line by line. But now I put together same line. I separated by what? Semicolon. So now if you want to run multiple lines or code together as a subroutine or as one function, you put it, separate them semicolon. The system will know, or you want to execute multiple lines, all one go. Yeah. So after that, you outside that just put in round bracket, then you follow by column equals sign. Column equals sign means delay assignment. Delay assignment means that please do not execute it. This is simply a function. So I assign my user-defined function called myF. This is my function, myF. Now, something funny right now is when you want to define user-defined function, right? Wolfram come up with something, it's not like that. You see, usually we call my function square with X. But Wolfram actually allows us to put in so-called pattern. Pattern is a concept in Wolfram that you accept things not just as input, but it recognizes pattern. For instance, you say, hey, among all the input here, I want certain input fulfill certain pattern that only can take. For instance, I will say, I want to put this inside pattern is image. That means that if you put in any this function, you key throw in this integer number. In the first place, you reject you. They say, hey, I'm expecting image. Why you give me the integer number? Or you can put in something like I underscore integer. You put in some real number, right? You say, hey, this is I expect input integer. Right? The pattern I expect is integer. Why you give me real number? It will not even execute in the first place. You do a filtering in the first place. But if I do not put anything behind, that means that I can accept anything. But whether you produce errors is another story. I accept it first. Yeah. So in this case, I make simple and X underscore accept anything. Now, after I accept anything, what we have to do is, you see this MYF is purple color. Huh? Now we run it one time, now it become black color. System already have this function register in the memory. So next thing here is you can start create actually user-defined local dialog box already. So this local dialog box, like this thing, I will not explain it in details here. So this is like something using pure functions, using a way to trigger user input. So that this user input, say, hey, please browse for the pictures. Then you can browse for pictures that you want. Let me see if I get any pictures. I'm not sure I have pictures. This is one of my recent Zoom meeting. Let me see. Where does it go? Some of my friends and yeah, immediately come out like that. So this whole thing immediately actually turned into actually users actually usable function. For instance, here you say I do not want to make it that difficult, and I can let me hide this part. I can use this one MYF. Now then you can go internet. Let me go internet, copy and paste any pictures. Let me go internet. Let me see. Recently, is there any national Okay, I get one from internet. I'm not sure what this event is, but let me see. This could be one of or Liverpool, yeah. Now immediately I strap it out. See, these two things are already quick in subroutine, then you can use this function immediately. Actually, you can try, it's quite a lot of fun. Yeah. Now, in a short nutshells, right, Wolfram actually, when you want to deploy it, it's not just actually able to run a local thing. Important thing is, like say, people want to use to be a workable solution that can be shared, can be published. It can integrate with so many external and internal sources for data exchange and visualizations. So there are several other things. I will not further explain it, but some of the common questions you might have, what's different Python from and MATLAB, what about MATLAB? What about Maple? There are some common questions about that, but this thing is like in the past 10, 15 years ago, I got asked about this a lot. This day, people still ask is common, yeah, but all those answers are already commonly available. It's like maybe 15 years ago, people asked, hey, what's this SUV and MPV? And yes, 10, 15 years ago, it's worth explaining. But this day, it's go a website, people give a lot of very objective comparison. Why? Then during a time, you need to use Python. Today, R is still popular. You can see, it seems like R getting less and less decline. Python coming up. Then MATLAB and Maple and Wolfram. And why we do? Some people are still using it. And why they are not dying? Why they are still going strong? What's the reason? Yeah, those are things that you can actually do some reading, yeah, accordingly. And also worth noting, today is the second last session. Next Thursday, Desmond gives some more in details about machine learning, automated machine learning. We never actually give free session like that, 2 hours. This year could be a last time because we have a lot of other. We still have some free public seminar going on, but we will not give such a long one because we have a lot of other actually committed seminar going along the way with projects. So hope they make good use of these last sessions. And in one of our training class, a very popular one is people want to know how to do integration with Python. Yeah. So Wolfram have full integration and many creative way integrating with Python. So this is one of our training class available also. And again, some of the tutorial available and getting more and more Wolfram side, but our approach always non-traditional. We will share with our experience what we think is helpful based on our past actually commercialization projects and teachings experience using Wolfram technology. But this website, several links are good to start with. Yeah, go to check it out. It gives you more structural way to give a quick overview on everything that you need to know. Yeah, so that you have different way to enlighten you. So I think today is where I close it for now on. If you do have any questions, I welcome you to put in a Q&A and chat room. If not, I pass the time back to you, Desmond.
Okay, thank you, Peter, for this compact 2-hour section on this programming. I hope you have learned a lot from him, but today he's not in a good conditions, as he just mentioned. He's just recovering from the COVID. So hope you all bear with him. I think next week we'll see you again on the next coming event, Fast Track to AI Machine Learning. Let me share the screen to you. If you are already registered for these sessions, you should be able to receive the reminder later. If you haven't registered before, here is the link you can just fill in to register. I already put this in the chat room as well. So next week, Thursday, 10 o'clock to 11 is about 1 hour or 1 hour plus sections on the AI machine learning. It's a quick intro. And after that, coming week, August, we have a full course on the 5-day section on this AI machine learning, 20 hours. The detail is in the link as well. This is the course we offer to the commercial, but we also make this time available for the academic in a special price. So do feel free to join us, or if any of you or your friends are in this area. Actually, this course is designed even for non-IT person, which we think that machine learning is essential for everyone nowadays. Also for today's certifications, here is the link as well. So for all of you, please come to this link to put in your name so you can get a certification as well. If somehow you do not receive the email after you fill in the informations, please write to us, because we noticed that some of our email have been bounced back from your server, or you go to a spam mail recently. So I believe many of you do not receive our reminder on today's section as well. Sorry about that. If somehow you do not receive any reminder from an email or WhatsApp on the next coming sections, you can always log in with the same Zoom ID as today as well for next week's sections. Sorry about that. We try to fix the server as soon as possible. And like Peter mentioned, if you have any questions, please feel free to put in the chat room, and we will be very happy to answer that. If you have a question later on after you try out with the handout, you do email to us. We'll come back to you again. Okay. And for those that came in late today, that you have not get the link to the handout today, I will put again in the chat room in a short while. Right. All right, I see there's a question in Q&A section from KK Kong. He said, for the mastering machine learning in 5 days, what platform or software will be using? We will be using the Wolfram Mathematica as well for this automated AI machine learning, because we have gone through a few different programs, and we feel that this is the most suitable platform, especially for beginner, to get into the machine learning algorithms easily. And we have already a lot of those templates, and that will be most easy to get started with if you are a new beginner in this area. You'll be appreciate how actually easy to use Wolfram language compared to maybe Python, compared to maybe MATLABs. You'll see how I do encourage you to come on next week's sections. Next week's section and will be more like an intro to how the machine learning is made in the Wolfram language. So after that, you will have a better idea how actually this can be easily done in this software. You'll be amazed. All right.
Yeah, but I think to make more precise, a lot of the things offered by Wolfram is not meant for beginners. It means that easier for beginners to start with to complete complex projects. So things more are going two directions. It's always a tussle between these two directions. Some are going back to more actually low level, so you have more control A to Z. If you're an expert in certain domain and also a good coder, of course you want more control, or you want to see everything on your own, control your fingertips. Is one thing. But for those who want to go into the particular area using this approach, the cost of making mistake development is far too high for you than the achieve. So Wolfram provide a bridge for that, so that you skip the low level thing, go high level. But another extreme is the level goes so high, the application becomes so focused, it get limited by how you can further expand it. Now today, a lot of AI machine learning actually development start position themselves as codeless, or something like, I don't know what's the term they call, codeless AI development. That means it's just that putting up block by block. Something like some of the website actually how to construct certain website with certain tool. It asks you to throw in block element inside that website auto construct. It looks very nice, but after that, it say come a solution. Hey, can I actually plug in some checkout box? I want to put in some big display here, a video that side. It suddenly say, oh, this cannot, that cannot. It's convenient if I to get certain result, but after I want to expand and build in something extra, then cannot. So Wolfram actually try a blend between these two worlds. It allowed you low level control, yet a high level actually achievement. Yeah, that's my.
Okay, I think that's it for today. I thank you for joining us this section, and we hope to see you again next week. All right. Thank you, and bye-bye. Have a good day then.